Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model for YOLOv8. Before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, today we are going to create our own custom object detection model for YOLOv8. So for that, first you need to install latest OpenCV and Ultralytics on your Windows machine. This is what Windows 11 machine. Of course, you can use this method for Windows 10 machine also. So first, simply open Python IDE, then go to the tools, manage packages, and search for OpenCV-Python, and click on search on PyPy. It will search for OpenCV-Python, click on install, and it will install OpenCV-Python. Then the Ultralytics package, Ultralytics, just hit enter, and just a minute, is typo mistake, Ultralytics, okay, Ultralytics, and hit enter. And as you can see, the first one, Ultralytics, click on Ultralytics and click on install, and click on install button, and it will install Ultralytics on our Windows machine. That's it, we have done with package installation. Now simply I have created the repository, and the repository name is YOLOv8 custom object. So just go to the code. I will mention the link inside description box, copy and paste the link inside the browser, then simply go to the code, click on download zip, and it will download our zip format repository. So we have done with downloading process. So now just open our file manager, go to the downloads, and this is what our repository. Right click, WinRAR, extract to our folder, and we have our folder, again same folder, and this is what our files. So first we need our video file. So I have created here with.txt file, which is the text file. So open with text editor, and this is the link for downloading the video file. So open new tab, Ctrl+V, enter, and it will open our link for the downloading video file. So click on download. Now it will download our video file. So friends, as you can see, we have downloaded our video file. Again, simply close all these things, go to the downloads, and this is what our zip folder. Inside that we have our file, the video file. So right click, cut, and just move our zip folder inside our main repository, which is YOLOv8 custom object main, and paste here. Then right click and WinRAR, and just click on extract here. It will extract our video file. So as you can see, excavator.mp4, this is what our video file. So let's just play the video file, then we will get the idea what is our custom object. So friends, as you can see, this is the construction site, and we want to detect here excavator. So we have, this is the first scenario, because we have here two scenario. This is the first scenario, and in this scenario we have 1 and 2. So we have two excavators. So we want to detect here both excavator. Simple. So this is what our first scenario. It's a time lapse video. So if I skip some frames, as you can see, it's moving, it's going there, and here as you can see, this is what our next scenario. Here also we have excavator. So this is what our first excavator, and we have here another excavator which basically moving from here. So let me just forward the video file. As you can see, this is the small excavator. So we have basically two scenario. First one is I have already shown you, and this is what our second one. So our goal is we want to detect our excavator. For that we want to create our own custom object detection model for YOLOv8. That's it. So just close the video file. Now what we want? First we want our images. So for that we are going to use our video file, and with the video file we are going to create the images. Simple. So for that I have created the img.py. So let's just open the img.py with our Python IDE. So go to the file, click on open, and downloads our repository, which is YOLOv8 custom object main, again same, and img.py. So this img.py is basically for creating the images using our video file. It will basically create the images with the help of our video file. So here, as you can see, I have mentioned the max frames. Here you can simply change the number. You can mention the how many basically number of frames, or not frames, basically how many number of images you want from the video file. So right now we need here 500 images from our video file. So, and then here, as you can see, the cv2 imwrite, here we want to mention the folder where we want to save our all images. So what we are going to do, inside our repository, as you can see, this is what our repository here, I am going to create a new folder. So just create the new folder and mention the name images, let's say images, and just click on that folder and go here, just click on it. It will show the path, the full path of our folder. So just copy it from here and open our img.py. This is what our file, and here from images, from here images, remove all the things, remove all, and just paste the path of our folder which we just copy. As you can see, so this is what our new path, C users free downloads YOLOv8 custom object main, again same folder, and inside that we create images folder. So here only we want to mention single quote, and then just mention R for recursive, and the img, here it is, as you can see, img, just remove this img and mention the object which we want to train. So our object name is, in this scenario, our object name is excavator. So excavator, that's it, done. Now it will create 500 images from our video file. Now we don't want to search for excavator images because we are going to use our own video file. So you can simply use this method for live camera also. You need to simply, here as you can see, cv2.video capture, here we are going to mention our video file name, which is excavator for this scenario. Of course, if you have the camera, so you need to simply mention here 0, index number of the camera, then it will start the camera, and simply you need to mention the images, how many images you want, 1000, 2000, it will create the number of images which you mention as a max frames. That's it. So simply you can use this method live camera also for video file. So I have mentioned the path, then we mention our object name, also we mention the images, how many images we want, we mention our video file name also. So let's just save the code, and if I run the code, as you can see, it started our video file. Now it will save our images using our video file one by one, the frame by frame. Simple. So we have another scenario, and that's it, done. So now if you go inside our repository, here it is, as you can see, we are inside the images folder. So this is what our repository, YOLOv8 custom object main, and this is what our folder, and inside that folder, as you can see, we have the images 496. We created 496 images from our video file one by one. So now we have our images, we have done with our data. Now we want to create the label for our data. So for that, simply we want our label EMG software. But the label EMG software is basically not working with latest Python version. So we want here Python 3.8 version. So for that, what we want to do here, we want to open our Microsoft Store and just search for Python 3.8. And we want to install our Python 3.8 version. So Python, just hit enter, and we have here, as you can see, the Python 3.8 which I have already installed. So Python 3.8, simply here you will see install button, just click on install and it will install Python 3.8 on our Windows machine, the Windows 11 machine or Windows 10 machine. So just close it. I have done with Python 3.8 installation. Now what we want to do right now, we have Python 3.10, so we want to change the version. So again, go to the tools, not tools, basically go to the run config interpreter, and it will open this kind of window, new options. So as you can see, the Python version. So just click here and search this line, C:users feed app data local Microsoft Windows app Python 3. Just select it, click on OK, and as you can see, we successfully change our version. Now we have Python 3.8 version. Now we can install label.img on our Windows machine. So now simply go to the tools, manage packages, and search for label.img and click on search on PyPy. And as you can see, the first package, which is label.img, just click on install and it will install label.img on our Windows machine. That's it. We have done with label.img installation. Now go to the run, go to the tools, and we want to open the system shell. So click on open system shell and it will open Thony system shell. Now simply run the command label.img like this way. As you can see, label.img, and just hit enter. As you can see, we successfully open label.img. Now we want to simply select our directory. So open dir, go to the downloads, YOLOv8 custom object main, again same folder, and we have our images folder. Select the folder, and as you can see, we have our images. Now change the save folder, again go to the download, same folder, again same folder, and images folder, select the folder. That's it. We have select open dir and we select the change save dir. That's it, we have done. Now here we want to select the YOLO and just create the rectangle box. So start from this excavator, select it and mention the class name, the label name, or we can say the class name, which is excavator for this scenario. Okay, we have done. So again create new rectangle box and select this one, excavator, click on OK and just save it. Next image, same way, create rectangle box, select our object, mention the label name, create the rectangle box for another excavator, the excavator, because we have only one class, so select excavator, click on OK. That's it, done. Click on save. Next image, create rectangle box, just draw the rectangle box, click on OK, again create rectangle box, draw the rectangle box, click on OK and click on save. That's it. This is how you need to train the images. Not train, basically, this is how you want to, in simple language, this is how you want to draw the rectangle box on each object frame by frame using label.img. I hope you all clear so far. So I have already draw the rectangle box. I have already draw the rectangle box on 500 images. Simple. So I am going to simply close the label.img software and I will show you inside the downloads. As you can see, I have created the images folder and here it is. If I open view in extra large icon, as you can see, this is the excavator 499 text, and inside that we have the rectangle location. Okay, simple. So and if I scroll down little bit, we have our images also, as you can see. So we have images and the text. So this is how, as I shown you, this is how you need to draw the rectangle box on the object which you want to detect with the help of label.img. Done. So now what I will do, I need to simply delete the images folder because I have already created the images folder. So I will delete this folder and I will move the downloads and images folder, right click, cut, YOLOv8 custom, and I will paste over here. That's it. So we have done with drawing the rectangle on our images. Now what we want to do, we want to create a new folder. So I will create, remember one thing, because inside the Google Colab file which I have created for training, I have mentioned the freedom tech folder. So you need to simply create the same folder name, otherwise the Google Colab file will not work, or if you want to create any other folder name, you want to simply change that folder name which I have mentioned. The freedom tech is the folder name. You want to simply change that folder name. Simple. So here I will create the freedom tech folder, new folder freedom tech. This is what our folder name. And inside that folder, simply click on the freedom tech folder. Inside that folder, again we want to create a two new folder. So first folder name is images. So let's just create images, and the next one is labels. So new and create folder labels. Labels, as you can see, labels, labels. That's it. So again, simply go inside the images folder, and here also we want to create two new folder, which is training and validation. So let's just create training and the new one folder is validation. Training and validation. So we create the training and validation folder inside our images folder. Now again go to the freedom tech folder, labels folder. Again here also we want to create training and validation folder. So let's just create training and validation. That's it. We have done with creating folder. So what we done, we create inside our repository, we create freedom tech folder. Then inside that freedom tech folder, we create images and labels folder. Then inside images folder, we create validation and training folder. Again inside same way, inside the labels folder, we create validation and training folder. That's it. Now what do we want to do? We want to go again just back, and inside the images where we have the data, just select one image, or we can say just select any file and press the Ctrl+A, right click and copy all these things and just go back, YOLOv8 custom object main, go inside freedom tech folder, images folder, training folder, and just paste all these things which we have copied from our images folder. So press just Ctrl+V. That's it, we have copied. Again go to the back, images folder, same for training folder. We copy inside the training. So go back and go inside the validation folder, just press Ctrl+V, it will copy all these things. Again go to the back freedom tech. So we copy all the data from our images folder to freedom tech images training folder. As you can see, we have copied. Then again freedom tech images validation folder. Now same way for freedom tech labels folder, validation folder, just paste all these things which we copied. Again go to the back labels, for training also just paste it. That's it, done. We have done. Now what do we want to do? We want to simply create a zip folder as a freedom tech folder. So right click to the freedom tech, WinRAR, and add to archive, click on zip, click on OK, and it will create our zip file, zip format file. Then as you can see, we have freedom tech.zip is ready. Now simply what we want to do, we want to open the Google Drive. So friends, as you can see, I have opened my Google Drive. So just right click and click on file upload and select the file freedomtech.zip which we just create. So click on open. Done. So now it will upload our file on our Google Drive. So meanwhile what we are going to do, we are going to open our Google Colab. So friends, as you can see, I have opened the Google Colab. Simply click on upload, choose file, and inside the repository I have shared the Google Colab file. As you can see, YOLOv8 object detection on custom dataset. Select it, click on open. Now it will upload our file on Google Colab. So friends, as you can see, we have successfully uploaded our file. So now just go to the runtime, then change runtime type, and here we want to select Python 3 T4 GPU, click on save and just click on connect. So friends, as you can see, we have successfully connected. Now simply we are going to run our cell one by one. So just run first cell, which is import OS, Then we are going to install the Ultralytics. So just select our next cell, it will install Ultralytics. Done. So move to the next cell, this one, from Ultralytics import YOLO, just select it. Done. Just scroll down. Then we want to test our object detection, so select it, next cell. It will download the image and it will save the result inside our folder. And as you can see, it's downloaded the image and the result is basically inside our runs detect predict. So we have, it means our YOLOv8 is perfectly working. That's it, done. Now we want to access our Google Drive inside our Google Colab. So just click on this cell, as you can see, from Google Colab import drive. It will ask to sign in. Okay, so connect to Google Drive, select your Gmail ID, click on allow. Done. We successfully allow. Then as you can see, this is what our zip folder which we have inside our Google Drive. So now what we are going to do here, what we want to do, now we want to unzip our folder. So next cell, just select it and click on. Now it will unzip our all the data. Then we have successfully unzip our Freedom Tech folder. So if you just click here, G drive, my drive, and freedomtech.zip, as you can see, we have here freedomtech.zip and just a minute. Just click here, dataset, Freedom Tech. As you can see, the folder which we unzip, which basically save inside the dataset folder. So dataset we have Freedom Tech, and inside that we have images and labels folder. Now just scroll down, next cell, and here it is. As you can see, this is the cell for training. From here we are going to start our training. But first we want to create the data.yml file. So the file which we want to create, data.yml, which basically we want to create inside content, dataset, Freedom Tech, and then data.yml. So this is what our dataset folder. As you can see, the dataset, inside that we have Freedom Tech folder. So we have Freedom Tech folder here. So here we want to create our data.yml file. So just select here Freedom Tech and here click on new file and mention the name data.yml. That's it. It will create our data.yml file. As you can see, we have data.yml. Then just click on that file. It will open our file, and inside this file we want to paste the code. So the code which I have mentioned inside data.txt file, inside the repository, our repository YOLOv8 custom object main, inside that I have mentioned what we want to paste inside the data.yml file. So the code is basically inside data.txt file. So just open it, copy and open our Google Colab. This is what our data.yml, just right click and paste. That's it. And now here just change the class name and mention our new class name, which is excavator. Done. And the class is basically one, because we are going to only train here one object. If you have two objects, so simply mention here comma, and in single quote mention your next object name, and here you want to change 1 with 2. It means you have now two classes. So right now we have only one classes, so mention the number of classes. The NC means the number of classes, and because we have now one class, so there is no need to mention second class. So we have done with mentioning our data.yml code. Done. Now simply we are inside the data.yml, because as you can see we have the cursor, the mouse cursor is inside our data.yml. Simply now press the Ctrl plus S from the keyboard we save our data.yaml code. Done. Now simply run the custom training cell, click on here. And friends, as you can see, it started our training. We have 100 epochs. As you can see, we have 100 epochs. So our training is started for our own custom object detection model for YOLOv8. So it will take some time. Meanwhile, I will pause video. So friends, as you can see, we successfully completed our training and our model is saved inside runs detect train 3 folder. So simply I need to go here runs, then detect, and then we have here train 3 folder, and inside wait folder we have our model which is base.pt. So when your process completed, it will show where the model basically saved. So as you can see, the results save inside runs folder, detect folder, and train 3. So in your case, it may be train 1 or train 2. So here as you can see, it's completely mentioned the train 3 folder. So simply we want to search for runs folder, then the detect folder, then train 3 folder, and inside train 3 folder we have waits folder, and inside that we have our model which we just created, base.pt. So just select here and click on download. Now it will download our model. And friends, if I go here in downloads, as you can see, we have successfully downloaded our base.pt model. So let's just open our file manager, and inside downloads, here it is. As you can see, we have our base.pt model. So we need to simply move our model inside our YOLOv8 custom object folder. So just right click, cut. This is what our folder, custom object, again same folder, and here we need to paste our model. Now what we are going to do, we are going to simply open our main.py. So this is what our main.py code. So I have opened with Thony Python ID, and here what we want to do, now we want to change our Python version. For label.img software, we change our Python version with 3.8.10. So now we have done with label.img, so we need to change our version, the Python version. So simply we want to go here, runs, configure interpreter, and here just click here, and we want to select the first option, which is by default Python for Thony Python ID, which is 3.10.11. As you can see, so we successfully change our version. Now here I just want to mention our model name, which is base.pt, and then we want to mention in cv2.video capture, we want to mention here, we want to mention our video file name. So our video file name is basically excavator mp4. So right click, rename, and just copy the name, and just open Thony Python ID, and here I will mention the name, okay, excavator.mp4. Then what we want to do, we want to create here our coco.txt file for the name, the class name. Simple. So what we are going to do, we are going to simply open again our folder, our repository, and here let's create new and the text document and mention the name. Just remove new text document, coco.txt, and we have only one class which is excavator. So excavator, okay, excavator, that's it. Close it, save. Now if I open Thony Python ID and save the code, run the code, and as you can see friends, it's successfully detecting our excavator, okay. So what we are going to do, simply start the cvzone_putText method, just a minute, like this way, and simply what we want to do, if you don't know how to install cvzone, so just open tools, run the command cvzone, and search on PyPy CV zone and just click on install. It will install a CV zone. Simple. So then we are ready. Save the code and run the code. And what we are going to do, just increase the thickness of rectangle. So I have mentioned here 2, the thickness of rectangle, it will increase now. And here, okay, as you can see, I have mentioned the class name at the bottom here. So if you want to go with rectangle top left corner, so just change with x1 and y1. I have mentioned x2 and y2, just change with x1 and y1. Then it will show the class name on rectangle top left corner. Now it's perfect. As you can see, we have here, this one is also excavator. This one is also excavator which is working. This one is basically stop. So we successfully detect a custom object. We successfully create our own custom YOLOv8 object detection model, and it's detecting our object which is excavator. Now we have another scenario. As you can see, this is what our another scenario. Here we have excavator. As you can see, this one is also excavator, which is small one. So friends, as you can see, we have successfully create our own custom object detection for YOLOv8, and we successfully detect our excavator. So I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.